This is lesson 4-2 from the Algebra Readiness textbook. Take out your notes, a sharpened pencil, and begin working on the study guide questions. Pause the video until you are ready to proceed. All right, the first question is asking us which number is divisible by 3 and explain. The first number, or the rule for divisibility by 3, is to take the sum of the digits and see if the sum is divisible by 3. So 1 plus 3 plus 5 equals 9, and 9 is divisible by 3. So the first one is yes. Letter B, 7 plus 7 is 14. 14 is not divisible by 3, so no. Letter C, 4 plus 7 is 11. 11 is not divisible by 3, so no. Letter D, 6 plus 1 is 7. Got ahead of myself. 7 is not divisible by 3, so 61 is also not divisible by 3. The next question, is 3,230 divisible by 9, and how do you know? Well, the rule for divisibility by 9 is to take the sum of the digits in the number. 3 plus 2 plus 3 plus 0 equals 8. 8 is not divisible by 9, so no. The next one. A group of 56 students must be arranged in rows. Each row must have the same number of students. If there must be at least 7 students in each row, how many possible arrangements are there, and what are they? Show the arrangements. Well, one thing that can be helpful is to list all of the numbers that are factors of 56. 1 and 56, 2 and 28, 4 and 14, 7 and 8. Those are all factors of 56. I could go, there must be at least 7 people in a row, so that's important. My options are having one row of 56 students. That's using this one. I could have 2 rows of 28. I could have 4 rows of 14 kids. Or I could have 7 rows of 8, or I could have 8 rows of 7. I can't have have 14 rows with 4 kids in each row because I have to have at least 7 students in each row. So that's where I need to stop. So make sure you're answering the question being asked and following the guidelines that they are laying out before you. For today's learning target, we are trying to write numbers in standard and exponential form. We are also going to be simplifying expressions that involve exponents. You can use exponents to show repeated multiplication. This is a power, 2 to the 6th power. In fact, take a look that the 2 is your base. Only the digit immediately before the exponent is your base. The 6 is your exponent. When you're talking about 2 to the 6th, that value is the power. So what does an exponent mean? It shows repeated multiplication. In this case, 2 to the 6th power is the same as 2 times 2 times 2 times 2 times 2 times 2. We call this expanded form. And we'll get to that in a little bit. When you write out an a power as repeated multiplication, that's expanded form. The value of the expression is 64 when you do the math. That is known as standard form. A power has two parts. A power has a base and an exponent. The expression 2 to the 6th is read as 2 to the 6th power. In the expression x to the 3rd power, the blank is 3. The word that needs to go in the blank is the word exponent. Please write that in your notes. In the expression 6 to the 4th power, the blank is 6. And in that case, the base is 6. So let's write down the definitions for the words expanded form and standard form. Expanded form is writing an exponent as repeated multiplication. So let's include an example. 4 to the 2nd power is 4 times 4. This is expanded form. Standard form is the normal way of writing numbers. So going back to our example, four to the 2nd is exponential form, saying that that equals 16. Now that part, the 16, that is standard form. That's the normal way we see numbers. So let's try some of these. In the next spot, in your notes, I'm going to ask you to fill in this chart. The first thing you're given is the power, 12 to the 1st power. And I am asking you to fill in the expanded form and the standard form. So 12 to the 1st power. Oops, I think that in your notes, I think this says expanded form. So let's change that. So expanded form would be 12 because it's 1/12. Okay, the next one is n. Oh, and the value is 12. And then n is the same as n to the 1st. So this is expanded. And your expanded form is the same as your standard form. Make sure that you note that if you have a variable and there's no exponent shown, that it means it's raised to the 1st power. Okay, let's take a look at the next one. 6 to the 2nd power. I'm just going to write right over the top. This is also said 6 squared. Make sure you write that down. Some people don't know that if it's raised to the 2nd power, that means 6 squared. Expanded form is 6 times 6. And standard form is 36. Now, exponents are not limited to whole numbers. Decimals also can be used in exponential form. So this is 2/10 to the 3rd power, which is the same as, taking a number to the 3rd power is the same as saying 2/10 cubed. Make sure that you write those two down. It's pretty important that you know that to the 2nd power is squared and to the 3rd power is cubed. So this is my expanded form right here, and this is standard form. -7 to the 4th power. This means the opposite of the quantity 7 to the 4th power. Now, what's important to note here is that only the 7 is the base. Only the 7 is being repeatedly multiplied. This means the negative sign stays right out here in front, and I'm taking 7 times 7 times 7 times 7 repeatedly 4 times. Whoops. So again, this is my expanded form, and this is my standard form of negative 2,401. Now, when you have parentheses around the negative number, that means that it's negative 8 to the 5th power. And so the base of this one, due to the parentheses grouping that number, negative 8 is the base and being raised to the 5th power. In expanded form, do you see that every 8 has a negative sign? Where look at expanded form up here. The negative was only out in front, and the 7s were all positive because the 7 is what was being repeatedly multiplied. In our last example, negative 8 is repeatedly multiplied. So this is my expanded form, and this, when you actually find the value of that, is my standard form. Couple notes. Any number raised to the 0 power is 1. And we're going to talk more about why that is, but for right now, let's just put this down. So 5 to the 0 power is 1. Negative 8 to the 0 power is 1. X to the 0 power is 1. It does not matter what the number is. If it's raised to the 0 power, it equals 1. Make sure you've taken good notes on that, and let's go on and do some practice problems. Here's a science application. A microscope can magnify a specimen 10 to the 3rd times. How many times is that? This is very similar to one of the quiz questions. What does 10 to the 3rd power mean? 10 to the 3rd power means 10 multiplied by itself 3 times. 10, this is my expanded form. 10 times 10 times 10 is the same as 1,000. This is my standard form. This is what this is the answer I'm seeking. All right, write this following expression using an exponent. This time they're giving me the expression in expanded form, and they want me to write it as an exponent. So I ask myself, what is the base? The base is whatever number is being repeatedly multiplied. In this case, it's negative 5. Notice it's in parentheses, and so my number is still in parentheses. Then I count. How many times is negative 5 multiplied? 3 times. So negative 5 to the 3rd power. Letter B. This time, I only need to put together the ones that are the same. The commutative property allows me to change the order that this is multiplied. So I have negative 2, and actually, I'm going to put that B on the end so that it's in alphabetical order. Times A times A times A times B. So, negative 2, and then I have A repeatedly being multiplied to the 3rd power, and then B. This is as simplified as I can get it. Notice I only put together the ones that were the same variable. Letter C, negative 5, or the opposite of 5 times 5 times 5. Only the 5 is being repeatedly multiplied. So I would write 5 to the 3rd power. This negative sign simply comes out in front. Notice how different this one and this one are, and how different they look when written in expanded form. It is often confused between A and C in people thinking that those two mean the exact same thing, and they surely do not. All right, I'd like you to pause the video and give these 3 a try. Come on back when you're ready to compare your answers to mine. All right, take a look at what I got. Compare your answers to mine. All right, in this part, simplify 7 to the 2nd power. 7 is my base. It's being multiplied by itself 2 times. So I would write 7 times 7, which is 49. Letter B is asking me to evaluate negative a to the fourth and negative a to the fourth in parentheses for a equals 2. So I'm going to substitute 2 in. The first one is negative 2 to the fourth. This one is with parentheses. In this case, only 2 is the base and is being repeatedly multiplied. So I'm going to write 2 times 2 times 2 times 2. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So this is 16, and this negative sign simply comes down in front, negative 16. Then when I solve the second problem, I would write that as negative 2 as my base because of the parentheses. Negative 2 times negative 2 times negative 2 times negative 2. You could put a dot like this between each one, or you could just use parentheses. Negative times negative is a positive times a negative is a negative, and then a negative times a negative is a positive, and I end up with a positive 16. Identify the bases and the exponent and write the problem in expanded form. So in this case, my base is whatever is directly before it. In letter A, only 2 is the base of the exponent, and only y is the base of the exponent 3. My exponents are the teeny tiny numbers in the upper right, so both 4 and 3. In expanded form, I would write the 2 being multiplied by itself 4 times, the negative sign simply coming out in front. Then I multiply that by y multiplied by itself 3 times. So here is my proper expanded form. In the next problem, my base is 8. My other base is m. But you might say, well, m doesn't have an exponent. But remember, back at the very first page, if there is a variable and no exponent is written, the exponent is understood to be 1. So go ahead and write that 1 in for to help yourself out. So 3 and 1 are my exponents. In expanded form, I would write 8 to the third as 8 times 8 times 8 times m to the first. In letter C, because there are parentheses around the negative and the 6, the base of the 5 is negative 6. The base here is t, and the base here is r. The exponents, remember, if there isn't one on any given exponent, on any given variable, it's understood that the exponent is 1. So go ahead and sneak that in there. So the exponents are 5, 1, and 2. In expanded form, I would write this as negative 6 multiplying by itself 5 times, then a t, and then 2 r's. Okay, make sure you've got a good understanding of that, and let's go on. What is the difference between negative 3 to the 4th power and negative 3 to the 4th power without the parentheses? Pause the video and write each of these in expanded form, and then compare the answer that you get. All right, here we go. For this one, you should have gotten that negative 3 is the base. So you would need negative 3 written 4 times. Negative 3 times negative 3 is positive 9. Positive 9 times negative 3 gives me negative 27. Negative 27 times a negative 3 is a positive 81. Now let's do this one. Without the parentheses, only the 3 is my base being multiplied repeatedly 4 times. 3 times 3 times 3. And there's a negative sign out in front. So 3 times 3 times 3 times 3 is 81, and there's still that negative sign. Do you see that this answer to the second one is negative 81, and the answer to the first one is a positive 81? Make sure that you have a good understanding of the difference. Now, what does this mean for us? Well, we've talked about order of operations already this year, and we worked with grouping symbols, including parentheses, and we worked with brackets, and we worked with absolute value signs, and we worked with a long fraction bar. All of those were grouping symbols. We skipped over the one where there were any terms with exponents, but not anymore. And then we multiply or divide in order from left to right, and then add or subtract in order from left to right. Please note, when substituting a negative number into an expression, always use parentheses around that negative number. Please highlight that, make sure you know that, put that in your notes. All right, let's do a couple examples of solving equations. All right. Using my order of operations, from left to right, left to right. Okay, there we go. We're going to simplify this. First of all, do I have parentheses? You bet I do. And inside those parentheses, I do the order of operations. There is only one operation to do, so that means I need to add. So I added or parentheses. Now I take 5 7/10 to the second power. You are going to have to do a side problem to do these. To shorten the lesson, am going to tell you that it equals 32 49/100. You will need to show your work on your paper in order to get that answer. Calculators are not allowed. 32 49/100 times 4. Again, you'll need to do a side problem, but my next step is to multiply. 129 96/100. And how did I get there? I multiplied. So my answer is 129 96/100. Now, if you're asked to substitute in values for the variables, make sure if it's a negative, you insert the number with parentheses around it. So let's rewrite this problem. Negative 2 times, now x is negative 2 to the third, so that's what went here, plus 4 times 3, because y is 3. Now I'm ready to begin solving using my order of operations. The way I have it written, my parentheses are not grouping any operations together. So I don't have any parentheses to do. Then I do exponents. So leave negative 2 here. Do not take negative 2 times negative 2 first. That's a common mistake. I need to solve this first. Negative 2 to the third power means negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8. So I'm going to replace negative 2 to the third power with a negative 8, and then continue to rewrite the problem. And how did I get there? I simplified the exponent. The next thing I need to do is multiply or divide from left to right. I see here that I have multiplication here and multiplication here. Negative 2 times negative 8 is a positive 16. 4 times 3 is 12. 16 plus 12 is 28. And my answer is 28. The main takeaway is that if you are going to substitute a negative number into an expression, that you always, always, always put parentheses around it as you put it in to the problem. All right, pause the video here, give these two a try, and show your steps that you use in the order of operations. All right, the first thing that I see is that I have an exponent here and an exponent here. 2 times 25 plus 4 times -3 times -3 is +9. +9 times a -3 is a -27. Then, my next step after I've done or simplified my exponents is to multiply or divide from left to right. So that would be 2 times 25 and 4 times -27. (27) times 4 is -108. You probably had to do a side problem to get that. Then 50 plus -108. What is my rules that we learned in chapter 2 about adding two numbers where one is negative? We subtract the two numbers and give the sign of the bigger number. And I get 58, but it's negative, or the bigger absolute value, excuse me. So then we added, and I got -58. For the next one, you inserted the -5 with parentheses around it. -5, then I started off by simplifying the exponent. 3 times 25 plus 6. 3 times 25 is 75 plus 6. The next step was multiplication. Then 75 plus 6 is 81, and I added. All right, notice that these are all following the order of operations. All right, let's give this one a try. This time, notice I have a decimal in the bunch. Pause the video, try this one, and come on back to compare your answers to mine. All right, 5 to the 0 power, we learned earlier that any number to the 0 power is 1. Then 75 hundredths to the first power is simply 75 hundredths. 1 plus 75 hundredths is 1 and 75 hundredths. All right, the last part. Pause the video, try these two, see if you've got it, and then come on back to compare your answers to mine. Now, normally the first step is always to do parentheses. And here, my parentheses are grouping 1 plus 4. Some of you like to write parentheses. Some people like to write add there, whichever is fine. Then I need to do the exponent. 3 times, make sure you don't take 3 times 5 first and then take it to the third power. That's the big mistake we don't want to be doing. So 5 to the third power is 5 times 5 times 5, which is 125. And I got that by simplifying the exponent. Then 125 times 3. If you have to do a side problem, I would expect most of you do. You get 375. Make sure that you're showing your work. 375. The last problem. Oh, I see I have a negative number, so I immediately will put parentheses around that. W is -5 plus 3 to the third plus 6. So what is my job here? I need to simplify my parentheses first. -5 plus 3 leaves me with -2 to the third power plus 6. Then do not take 7 times -2. I must simplify the exponent first. -2 to the third power is -8. Seven times -8 is -56. That was multiplying. And then -56 plus 6, I am adding two numbers with different signs, so I subtract, and I get 50, and I give it the sign of the bigger absolute value, which is negative. And so I add, that's how I got there. My answer is -50.